Hey mathematicians, let's talk about equivalent or equal ratios and how we can write them using ratio tables. All right, so our first key point is that two or more ratios are the same if the parts of the ratio increase or decrease, that means go up or go down, by the same multiplicative scale factor. Multiplicative kind of sounds like multiplying. It means multiplying, or its opposite, its inverse, dividing. So for example, here you can see that I said that 3 halves, or 3 blueberry muffins for every 2 blueberry pumpkin muffins, is the same as 6 blueberry muffins for every 4 pumpkin muffins. And I gave you a picture down here. We can see the 3, I guess we're going to assume these are blueberries, or red berries. 3 blueberries for every 2 pumpkin. Now this is the same as 6 to every 4 because I can see that I keep the ratio the same. Even though I have like double the amount of muffins, it's not like I just added a bunch of random ones. I added them in the same ratio. 3 blueberry to every 2 pumpkin. That's what makes them equivalent. An easy way to keep track of your equivalent ratios is to put them in a ratio table. So here we have a ratio table that's comparing puppies to kittens. For every 5 puppies, there are 4 kittens. So here are my 5 puppies and my 4 kittens. That means if I wanted to say, well, I want more puppies, 5 isn't enough, I couldn't just say, well, I'm going to take a 6th. If I'm keeping the ratio equivalent, I have to get 5 more puppies, which also means that I have to get 4 more kittens. So I double my ratio by a scale factor of times 2, and now I have 5 times 2, I have 10 puppies, and 4 times 2, I have 8 kittens. A really easy way to show that is I draw an arrow from the 4 to the 8. I did 4 times 2 equals 8. The exact same thing has to be true for the puppies. I can't do kittens times 2 and puppies times 5. I have to say I'm getting 2 groups of 5 puppies and 4 kittens, and that makes 10 puppies and 8 kittens. I could even say, well, that's not enough. I love all the animals. I need 100 puppies. But if I'm going to get 100 puppies, or 10 times as many puppies as you see right here, because 10 times 10 is 100, well, then I'm going to need 10 times as many kittens. 8 times 10 is 80. Let's check out all my puppies and kittens. Oh my gosh, I'm going to have a lot of puppy pee to clean up. But you can see that in all of this, I kept my initial ratio. There are 5 puppies to 4 kittens. 5 puppies to 4 kittens. I just did it a whole bunch of times. That is why they are still the same equivalent ratio, because I'm not changing the comparison, the number of puppies I have for every certain number of kittens. Now, I can use those multiplicative scale factors to find out parts that I don't know. I'm like, okay, I want 16 kittens. That's the most kittens I can handle. Well, how many puppies comes with those 16 kittens? So your strategies are, you can look around in your ratio table and say, okay, I know how to get from 4 using multiplication or division to 16. Yeah, 4 times 16, I know that one. 4 times 4 equals 16. So I'm going to have to do 5 times 4 to get my number of puppies. Maybe you didn't see the 4 to 16, but you're like, oh, I know if you double 8, if you do 8 times 2, that's 16. That's fine. You can use that one as well. You just have to then go to your 10 and say, well, 10 times 2, that's going to be how many puppies I have. You'll notice that 5 times 4 is 20, just like 10 times 2 is 20. I have 20 puppies if I want 16 kittens. So those are equivalent ratios in ratio tables. They're really easy to draw. You can just draw yourself a little chart like this, or it could go this way. Doesn't really matter so long as you're labeling your 2 quantities and you're making sure that the numbers match the labels. Like, you don't want to accidentally say you have 5 kittens and 4 puppies. That's not the ratio. So make sure that your labels match your units, your numbers. Another way to do it is if you're just trying to go to one certain number, you don't need a whole ratio table. You can basically do like 2 parts of a ratio table in what's called a proportion. A proportion is when you set one ratio, usually in fraction form, equal to a part of another ratio, and you're trying to figure out what the missing part is. So you can see here, I had a full ratio in 4 over 5, 4 to 5, and I'm missing this unknown piece right here. Again, we're using only multiplication or division. You're going to look for a relationship between the numbers that you already have. 5 and 20. Well, I know that 5 times 4 is 20, so you're going to have to use the same scale factor. 4 times 4, that would give you your missing part. One way to solve proportions is to look for horizontal relationships, like we just did a side-to-side relationship. Another way is to look for vertical, oops, that went the wrong way, vertical or up and down scale factors. So let me show you real quick 2 examples. Here is my first one. I always like to start at my unknown, which is a lot of times represented by a letter, a variable, and I always start diagonal. I'm going to start with this 4. From the 4, I'm either looking horizontally, side to side, or vertically, up and down. Only times or divided by. 4 times something or 4 divided by something that equals 10. I'm not really seeing it there. 4 times something that equals 32. Oh yeah, I can see that. 4 times 8 equals 32. So I'm going to go down here and say 10 times 8. My answer must be that x is 80. Over here, starting at x, going diagonal to the number, diagonal from it, that's where I'm starting. I could go horizontally here, or I could also go vertically here. Just to show you a vertical, I'm going to show you that one. 20 times something that equals 5? No, but 20 divided by something equals 5. Divided by 4. That has an answer of 5. So I'm going to go over here and say 4 divided by 4. X equals 1. So this is basically taking 2 parts of your ratio table and working on them next to each other with an equal sign. If you don't like that, then just stick with your ratio tables.